Hi, I'm Dr. Mannheim from the biology department. I am honored to introduce Dr. Mike Tocci to all of you. He has a lengthy and impressive bio, and I'm sorry, but under rules from my boss, I have to talk about it. Dr. Michael Tocci is Associate Dean of Research at our STEM department, the New Jersey Center for Science, Technology, and Math. And he has more than 35 years of experience in pharmaceutical drug discovery and has had key leadership positions in Merck, Cell and Molecular Technologies, and Sanofi. So he's had a very interesting career. He received a bachelor's in science in biology from SUNY College, Cortland, and his PhD from Penn State University in microbiology with a focus on virology. And he completed his postdoctoral work on cell biology at the Roche Institute for Molecular Biology before joining Merck Research Labs in 1981 as a senior research scientist where he specialized in antiviral research. At Merck, Dr. Tocci led the molecular immunology group, where he focused on the role of cytokines, chemokines, and inflammatory mediators in immune and inflammatory diseases. He's best known for leading the efforts and elucidating the molecular mechanism of immunosuppressant cyclosporin A and tacrolimus, and then a whole bunch of things that, even if I try to pronounce them, we might get confused. Once he left Merck, he co-founded Cell and Molecular Technologies, a biotech firm specializing in contract research. He joined Sanofi's predecessor Aventis Pharma in 2001 as U.S. head of genomic sciences and rose to become vice president and global head of immunoinflammation, drug discovery, and preclinical development for Sanofi. He has published over 50 papers, you're my hero for that, in leading journals and contributed translational studies to the discovery of drugs such as Singulair for asthma treatment, Vioxx, which is a non-steroidal anti-inflammatory drug, and various other drugs that help treat lupus, rheumatoid arthritis, eczema, and multiple sclerosis. He's been a reviewer for numerous journals and on grant review committees, and he's a recognized expert in translational research in modern drug discovery and a true asset to Kean University. So it is an honor to be able to introduce him to talk about the RFI today. I tried to make it fast.
Thank you, Elizabeth, and I'm really very excited to be here today. I can't thank Dr. Teasdale and Dr. Mannheim enough for inviting me, I'm really excited to talk to you today. Not so much about science, a research talk, but to give you an idea of an exciting opportunity that exists here at this university, okay? So the first thing that you'll gain from listening to Elizabeth describe my career is that I'm really old, okay? So hopefully some of that experience can be brought here and can be used to benefit students and faculty alike. So my talk today is not just to students, okay? If there are faculty in the room, there's an opportunity here for you as well to think about perhaps maybe joining the initiative that I'm going to talk about, okay? So for today, I'd like to spend, most of the time talking about something that we've started now almost 3 years ago over in the New Jersey Center for Science, Technology, and Mathematics. It's called the Research First Initiative, okay? And I'm really excited because Dr. Teasdale and Dr. Chang, felt that there was an opportunity here not only for the students in the STEM programs, but also for students here in the College of Natural and Applied Health Sciences to participate in this program, okay? And not only the students, but there's an opportunity even for faculty. When we started the program, one of the faculty from the chemistry department, Dr. Stokes-Hubie, actually joined one of the chemistry projects that we run within the Research First Initiative. And this year, Dr. Mannheim is actually going to be involved as well. So I really want to talk to you really about what this all encompasses, okay? And if you have questions, please this is very informal, so, stop me, ask questions if you have anything. I only have like 5 or 6 slides, okay? So hopefully they won't put you to sleep, but hopefully you will find them quite interesting and informative, okay? So what exactly is the Research First Initiative, okay? And why are we doing it, okay? So I assume that all of you here are science majors of some sort, okay, or chemistry or perhaps math, computer sciences, but you're interested in science, computer science, mathematics, some form of the kind of empirical sciences, okay? Well, the Research First Initiative is really just what it says. It's a research mentoring program. And the reason it's a mentoring program is because we know that the success of students, that your success is closely linked to the level of mentorship that you receive throughout your educational career, okay? And one of the things that we really pride ourselves on here at Kane and certainly over in the STEM Center is the ability to mentor students, okay? Well, it's not just about mentoring them on, with their daily problems and things, but it's actually mentoring you through science, okay? And the approach that we're taking is to involve you as early as we can in real, live, authentic research, okay? And I'm going to keep coming back to this point throughout the throughout the talk, okay? So how many of you have sat in a classroom taking a math or a physics course or even chemistry or whatever and sat in that classroom and said, why am I sitting here in this class? What am I learning? What am I going to get out of this, okay? And things. I'm a biology major. I'm a math major or so. Well, I went through that very thing. When I was an undergraduate, I was a biology major. And the requirements for me as a biology major required me to take calculus, 2 years of calculus for math majors, and I was horrible in math, okay? And I had to take physics, so not only did I have to take the calculus, but I had to take physics for physics majors, which used the calculus that I really didn't, fully comprehend how to use, okay? And I always wondered, why do I have to take physics? Well, little did I realize that further down in my career that I would actually use these things, okay, both on the math side as well as on the physics side, even though I was involved in biology, life sciences, and drug discovery, okay? So that's something that is important. But sitting through those classes is often a real challenge. Sitting there just learning material by rote, memorizing things, trying to figure out how it works, why, what does that mean, etc. Okay? Well, the Research First Initiative is really an approach that allows you to learn by doing, okay? Sounds very simple, almost sounds trite, okay? But you're actually in the lab doing experiments on the types of principles that you are learning in class, okay? So that's really important, okay? Secondly, many of you perhaps think about becoming a scientist, maybe not, maybe you don't know what it's all really involved in or so, but it gives you the opportunity to experience what real scientific discovery and actually failure is like. What is it like to work in a laboratory on a problem or a question that you do not know the answer to, for which there is no known answer? You have to discover the answer. You have to figure out how to attack the problem and solve it, okay? So that's important. That's the second important point, okay? I kind of mentioned this next one, working alongside faculty as mentors, okay? Well, it's not just the mentorship piece, okay? Faculty can help you, they can advise you or so, but how many of the faculty here are actually role models to you? How often do you see someone and say, boy, I would really like to be like that person, or I wish I had the skill set that that person had? Well, mentorship in this program really does mean that. It means working alongside people who are actually role models for you and the career that you might seek, okay? Now, some people tell me, when we first proposed this, that, you know what, I'm going to be a biology teacher or a chemistry teacher, and I don't really care about research. I don't want to do research. And, you know, that's fine. Research isn't for everybody. But the thing that I tell those people is that you may be a teacher, okay, in high school or even grammar school, but some point in your career, a student is going to come up to you and want to do a research project. And your ability to know how to do research, to understand what the process is like, and to guide that student through a real scientific experience, okay, in terms of learning and discovery, is equally important as just becoming a research scientist. So there's opportunities here for teachers as well, okay? And I think I said this before, is that this is really meant to be an aid and a help in a pathway to success in your academic and your career goals, okay? So I want you to keep all of that in mind. So there's a little bit more detail about what I just said. So you're sitting here wondering, so, okay, why should I do this, okay? I'm not going to kid you. It's work, okay? You have to dedicate yourself to what this initiative entails, okay? But as I said, it's a kind of transformative learning experience. It's moving away from just simple lectures and actually learning by discovery, by doing, okay? And the reason this is important is because it helps you build confidence and it builds identity, okay? How many people walk into a lab and they go, boy, I don't think I can do this, okay? Well, the first time you do an experiment and you realize that, wow, this is not so bad, or I understand what I'm doing, it builds a level of confidence in you that you can keep doing this and you can keep building on that experience, okay? So again, that's important. It also helps you build an identity. How many students don't really understand or believe that they could actually be a scientist or act like a scientist, okay? These two things, confidence and identity, go hand in hand, okay? And not everybody is at that point where they can make that decision, and this can actually help you do that, okay? And perhaps one of the most important things is that this is a program that helps you develop the critical skills that you need to succeed in life. So your professors and the university, we all talk about skill sets of critical thinking and problem solving, communication, and quantitative ability, okay? How to express yourselves in numbers, how to interpret numbers, okay? How to solve a problem, how to think about what's real, what's fake, what the basis for that statement is, okay? And how to assimilate that information into a real problem-solving mechanism, okay? That's part of what this is all about, okay? And I can guarantee you that if you begin to develop these sorts of skills through a program like this, it will be something that carries with you throughout the rest of your life, okay? These are essential skills, not only in science, but throughout any career that is on the horizon for many of you, okay? There's the mentoring piece, okay, and things. And the way that this program works is that you actually join a laboratory team, okay? A small group of students, not a huge group. There are only 6 to 8 students in each of these research teams, okay? So you're not only there with the faculty member, but you're there with your peers as well, okay? So how often during my career did I turn to, my lab mate or, someone else in the lab and say, do you understand that? And someone would say, well, yeah, here's how it works. And all of a sudden you go, oh, okay, now I get it. So you don't have to feel embarrassed, or you don't have to think that you're the dumbest person in the room because you didn't understand a concept. Not everybody gets it. And oftentimes your lab mate is going to come to you and say, I didn't understand that, and you're going to be able to explain it. Okay, so those things are absolutely critical in terms of the way that we run this program, okay? And then if you have any doubts at all, there are real-life advantages to this. There is true value in gaining research experience and the types of skills that will enable you to, move forward in a career, okay? And I'm just going to give you 2 examples, okay? So Everybody, unless you've been living, in a cave somewhere, knows that in the mid-2000s, this country went through one of the greatest recessions it's ever seen. Huge job loss, layoffs, economic downturn, and so forth, okay? So, if you actually look at the unemployment rate and who had the jobs during that period and how much those individuals were paid, there's an amazing realization that comes out, okay? So, if you had a 4-year college degree that focused in STEM, okay, science, technology, engineering, or math, okay, versus a college degree that was not related to STEM, okay, the unemployment rate in STEM during the recession was 3.2%. And that number is almost the national average that existed before the recession, okay? So there's almost no change in the unemployment rate against people who were employed or had a STEM degree. But if you didn't have a STEM degree, the unemployment rate was 8.2%, more than double, okay? Those people were out of work, unable to find jobs, okay? Not only that, but if you had a STEM degree and you were in that 3.2%, chances are you were able to find another job relatively quickly, okay? Now, if you had that 4-year STEM degree, your starting salary was close to $80,000 a year, okay? Not too bad, okay? For a non-STEM degree, okay, your starting salary would be $41,000, almost half, okay? Now I'm going to tell you a story about how I grew up, okay? So I was fortunate. I came from a big family, both on my mom's and my dad's side, okay? But we were actually pretty poor. I put myself through college, okay? Went to grad school, postdoced, and finally got a job. And my dad used to tease me all the time, basically saying, when are you going to get a real job, okay? Because as a graduate student, I earned less than $4,000 a year. As a postdoc, I earned less than $12,000 a year. But when I got my first job, okay, I actually made more money than my dad was making at the time that he retired, okay? So, and my dad did not have a college education. He only had a high school education. So there's a lot of benefit here for you, okay? Now, what about jobs, okay? If you're looking for a job in a core STEM field, like math, engineering, computer sciences, or a health-related STEM field, like science, medicine, nursing, research, okay, and things, these two sectors during the recession actually experienced job growth when the rest of the economy was experiencing job declines, okay? So core STEM, the number of jobs rose 19% during that period, and in health, it rose over 100% during that same period, okay? So the idea here is to stick with earning a degree in science, technology, and mathematics, and gaining as much experience in those areas as you can that will allow you to get a job, okay? And then finally, the RFI provides you with real hands-on experience. You learn how to use instrumentation, you learn how to do experiments, you actually learn how to keep lab notebooks, etc., okay? All of these things are highly valued by employers. They allow you to differentiate yourself when you go for a job, okay? And you are sought after by employers, not as, in terms of job opportunities, rather than having to keep searching and searching and searching for a job. Okay, so that's the commercial part, okay? So let's talk a little bit more about what the RFI entails, okay? So, like I said, we started this program back in 2014, 2015, okay? And we've had students come through this, okay? Over in the STEM Center, and we've actually had students from Natural and Applied Health Sciences come through this program as well now, okay? And in fact, we're, the first students that have gone through this are going to graduate this year, okay? So, now, in the STEM building, okay, these courses are all electives, okay? and they would be here as well. So there are choices. You don't have to enroll, but if you decide to enroll, you can do that, okay? So over in the STEM building, there are 2 required courses. One is this research methods, which is not offered over here, okay? And the other is this GE 2024, Research and Technology. And you guys take a similar course. It may actually even be the same course, okay? These are required courses. So we require these as part of the RFI experience, okay? But then there are 2 courses that are the core of this program, that are electives. The first is called Research Experience, and the second is called Advanced Research Experience. So 2903 is a 2-credit course, and 3903 is a 3-credit course, okay? And we try to enroll students in 2903 as early as possible. Students can enroll in their spring of their freshman year or the fall of their sophomore year, okay? Now, some students, again, from the College of Natural and Applied Health Sciences, because of your schedules, you might not be able to do that. So there's no reason why you couldn't enroll later in the sophomore year or even in your junior year, okay, if you wanted to, okay, and things. And then we ask students to actually take these 2 courses. You don't have to take both. You could take one and not the other, okay? But we ask you to take them in sequence. So you have to start off with 2903. You can't just skip to 3903, okay? And then as a result of this experience, you wind up presenting a poster at Kane Research Days and perhaps producing some sort of senior paper, okay? Now, over in the STEM building, if you complete this sequence, you will get a certificate, and we're working with the registrar now to actually get this title, Distinction in Research, put on your transcript, okay? Now that would be something that is up to Dr. Teasdale and Dr. Chang, okay? But regardless of whether or not it goes on your transcript, you'll actually receive a formal certificate from the university, okay, for going through this program, okay? Now, there's another track here, okay, which is a bit more extensive, okay? It not only includes the 2 requirements, the 2 research experience courses, but it encourages students to continue working on their same research project, okay, doing independent research. And we ask that you take 4 to 6 credits of independent research during your junior or senior year, okay, and then produce a poster at Kane Research Days and a research summary paper. If you do that, you get an honors distinction in research, okay? A certificate stating that, or and again, we're working with the registrar to get this distinction on your transcript so that when you go to an employer, you can actually show them, or if they ask about it on your transcript, you can explain what it's about, okay? So, so that's an idea. So now, what are these courses all about? So I described to you that students enroll in these courses. There are different sections of these courses, which are on the next slide. So right now, we have 10 different opportunities for students to actually work in authentic research, okay? And when I say authentic research, okay, you're not working out of the biology lab manual or the chemistry lab manual. You're working alongside a professor in the lab on a research project that is already ongoing in his or her lab, okay? And it is a project that is supported either by a university grant or a government grant, okay? Or some sort of external collaboration. It could be with a company, it could be with another university, et cetera, okay? But you don't get to pick the project, okay? You don't come in and say, hey, I want to work on, beetles or something, okay? That's not how it works, okay? So, in analytical chemistry, Dr. Ramanathan is studying compounds from medicinal plants. They're trying to actually isolate and characterize compounds that have medicinal qualities and test them using analytical techniques. So students in this stream learn mass spectrometry, nuclear magnetic resonance imaging, they learn gas chromatography, how to isolate compounds, and how to test them, okay? In bioinformatics, this is one where if you have a math or a computer background and interest, okay, this is one where Dr. Mayer is actually studying bacteria in water systems, okay? Pristine versus polluted versus runoff from storms, et cetera, and things, okay? And actually looking at the microbiome. These are the bacteria that live in these environments, okay? And looking at how those microorganisms, the populations, change over time, okay? Now, there are thousands, perhaps even hundreds of thousands of organisms that live in these things. So this is really a metagenomics problem, okay? It involves computer science, data analytics, okay, and mathematical, statistical analysis, okay? So just because it says bioinformatics doesn't mean that it's not something that someone who's a computer scientist might not be interested in, okay? And this is the basis for personalized medicine, okay? How people are actually being looked at to understand what type of disease they have and how to treat it, okay? So this is extraordinary. Cancer biology. Dr. Coniglio is actually studying glioblastoma, okay? So again, unless you've been living in a cave for the last 6 months, glioblastoma is the cancer that Senator John McCain was just diagnosed with, okay? So glioblastoma is an incurable cancer, okay? And it has a very short life expectancy once diagnosed, okay? Maximum of 2 years, okay? So Dr. Coniglio is actually studying how this cancer metastasizes and the cells that are involved in that metastasis. And it turns out that cells of the immune system are communicating with the tumor cells and reprogramming each other so that it can actually promote metastasis. And understanding the signaling pathways and the mechanisms that are involved in that are the basis of his research, okay? 3D visualization. Now, I know here in the computer sciences group, there's a lot of work that goes on in 3D. I don't know how many of you know across the street, we actually have a room. We have what we call the CAVE, the Computer-Assisted Visual Enhancement System, okay? It's a room about half the size of this that actually has a 3D environment in it, okay? And things. And we have now the ability to import any kind of data. It could be data from the arts. It could be data on voter registration. It could be data on rainfall from Hurricane Harvey. Or it could be patient data from a cancer trial. Or it could be MRI imaging from a patient with a brain tumor, okay? To import that and actually display the data visually so that you can actually look at the data and see different patterns in the data more easily, okay? And again, this involves a lot of computer science, okay? Statistical analysis, programming, et cetera, and things. And there are a variety of projects here. Dr. Joyner happens to be an astronomer, okay? And the way that he uses this data is he's actually looking for new planets amongst the stars. So he actually looks at little points of light and asks whether or not those points of light are somehow perturbed in a way that would indicate that they might be a planet that supports life, okay? And things. So again, the sorts of possibilities here are enormous, and this is cutting edge technology. You know, you see data visualization and virtual reality almost everywhere these days, okay? Dr. Mannheim is going to be working on Drosophila genetics, looking at fertility genes, okay, and reproductive genes in Drosophila. And if you really want to learn genetics, this is a place to really do that, okay? So if you have a passion for genetics and you really want to learn, that's one of the things that you should really go after, okay? Microbiomes, another hot topic, okay? So microbiomes or are the populations of bacteria, like I said before. In this case, with Dr. Hayes, they are the bacteria that live on and in you, okay? And we know that perturbations in that population of bacteria can affect your health, okay? We know that in diseases like inflammatory bowel disease, Crohn's disease, that these populations of bacteria that reside in your gut are influencing your immune system, okay? And that there's a breakdown in your immune system because of that, okay? And that they are major contributors to disease. So Dr. Hayes is developing technologies and techniques to actually understand the microbiome, okay? I don't know how many of you know Dr. Merritt. Hopefully some of you know Dr. Stokes-Hooby. Okay, so there's two different streams or research streams that they do, and they're both related. Dr. Hooby uses this technique called microwave chemistry. They actually do the reactions in a microwave oven. Okay, it's pretty cool. Okay, and you could do large numbers of reactions in these ovens, almost in plates. Okay, so you can make libraries of compounds. Okay, and Dr. Hooby and Dr. Merritt are actually working with Dr. Caniglio to try and discover compounds that are drug-like that might actually inhibit the spread of glioblastoma. So these three streams are actually intertwined with one another. So if you enroll in one of these, chances are you're going to gain a lot of experience or what we call translational experience, okay, across these different domains, okay? Now, Dr. Merritt also comes from the pharma and the biotech industry, and he is a highly skilled, what we call medicinal chemist. He's the guy who actually designs and makes compounds that eventually become drugs, okay? And I can tell you that medicinal chemistry is not taught in undergraduate schools, okay? It's rarely taught in graduate schools, okay? It's usually taught by word of mouth from one medicinal chemist to another, teaching you once you get a job, okay? So if you come out of a program with skills in medicinal chemistry, I can guarantee you that you will be highly sought after, okay, and things, because that's unheard of. One of Dr. Merritt's students just got accepted into the chemistry department at the University of Kansas, okay, which is actually one of the premier chemistry departments in the country, okay, is one of the best chemistry departments in all of the United States, and she's there now, okay? Now, if you like math, and you know Dr. Farnham, he's a mathematician. He actually studies light waves that are involved in telecommunications, okay? And not just ordinary light waves, you know, the ones that are symmetrical. He looks at non-symmetrical light waves and understands how they behave because they are useful in data processing, okay? In non-symmetrical waves, you can actually compress more data, okay? More information into those waves, okay? They're also useful not only in optical waves, you know, fiber optics and things like that, but they're also used in facial recognition, voice recognition, okay, and things. So there's a lot of opportunity here. And then finally, if you're a teacher or you want to be a teacher, we even have a stream in STEM education, okay? And that's Dr. Baldwin. And what they are looking at is they're doing research on how students perform in school districts on these PARCC exams that the state now requires, okay? Because they're actually going to change the PARCC exams, okay? And what they're looking at is, you know, the demographics of the school district itself. Are poor school districts performing differently than more affluent ones? What the level of money that is provided to these school districts, et cetera, and things. So this is really a great opportunity as well, okay? So those are the streams, okay? Now, it's up to you, okay? If you're interested in one of those, you could choose, okay? And things. But there are some requirements, okay? First of all, we want you to succeed. Okay, that is absolutely key. Okay, so at least on the STEM side, we ask that you have now, if you're a freshman, we actually look at your high school records. Okay, if you're already matriculated here at Kane, we'll just look at your transcripts here. Okay, we'd like you to have a 3.0. okay? And we'd like you to have at least a 3.25 in science or math. Now, if you're here and you just go, oh, don't have that, okay? Well, don't despair, okay? We do make exceptions, okay? And it's really based on you, okay? And things. We may look, if it were me, after taking calculus and physics, I never would have been able to enroll in this, okay? And things. But yet, when I was an undergraduate, I was able to do research because the professor saw something unique in me, okay? And that's one of the things that we look for, okay? So don't despair. You have nothing to lose by applying, okay? So how do you apply, okay? So one of the things, okay, is that you must interview with the faculty member whose research topic you're interested in, okay? So if you're interested in cancer, make an appointment, go see Dr. Caniglio, talk to him after class, whatever, okay? Same thing. That is an absolute requirement. You must interview with the research professor, okay? If you want to work on genetics, grab Dr. Mannheim, okay? Her stream is going to be offered in the spring, okay? Grab her and tell her, you know, what you want to do, okay? And like I said, just because you don't necessarily have all the GPA requirements, we do make exceptions, okay? But it's really based on your enthusiasm and your desire to do research, okay? So that's a big, big hint, okay? So if you go in and you don't know what you want to do and you kind of, I don't know, maybe, blah, 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 chances are no one's going to want to take a chance on you. But if you come in there and you say, I'm really interested in genetics, I've looked at your stream, I've looked at, you know, I've done some background reading already, someone's going to want to take a chance on you, okay? So consider that, okay? So some streams do have some prerequisites, okay? So if, you know, if you're taking medicinal chemistry, okay, you need to know chemistry, okay? So you need to at least finish your chemistry class before you take that stream. If you're going to go into one of the computer-based ones, you probably need to know programming, okay? So you need at least some basic skills in programming. Do you need a course? Maybe not, but you need to be somewhat proficient in it, okay? So if you want to do this and you're thinking, well, I can't do it this year, I want to do it next year, try and take the programming course as quickly as possible, okay? And again, you should talk to the professor because some of them may say, you know what, I can, you know, the project that I have in mind, I can teach you the level of programming you need and things. You don't have to worry about, you know, having a full course or so, because these projects are real projects, okay? They change over time depending on what the research question is, okay? So, So that's just a little bit more advice, okay? And I think this is my last slide. So I think I've covered some of this, okay? So these are some frequently asked questions, you know. What if I don't meet the GPA requirement? Like I said, try anyway, okay? How do I enroll? So all of these courses are listed under the course number, okay, in Cane-wise. Enrollment is by petition, okay? So you can try to register for it, okay? And each stream will not only have the course number, but it'll have a short descriptor, like maybe cancer or, you know, med chem or, you know, something that describes it. And it should show the instructor as well, so you'll know which stream to apply for, okay? And again, if you interview with the professor, you'll know, that's one of the questions you should ask, what stream is yours, okay? And they'll tell you, okay? So enrollment is by petition, and again, slots, there are only 8 slots per stream. And the reason for that is that we want to make sure that you get the mentorship that is needed, okay? That you get the one-on-one time with the professor, that you're not in there with a zillion other students, okay, competing for the professor's time, okay? And things, okay? So we talked about prerequisites, okay? There are 2 other points I want to make. Can I change streams, okay? So every once in a while we get a student who says, you know, I enrolled in med chem and I want to switch to wave optics. And you go, whoa, okay? So we really want you to think carefully about the stream that you choose. And the reason for that is that we want you to be able to work on a problem over a period of time, not to jump from one thing to the next, but really understand what it takes to do research and to understand the problem, okay? Now, some opportunities to change are there, okay? And what we like to tell students is that if you really want to change streams, pick a stream that is related in some way to the original stream you picked, okay? So for instance, let's say you pick MedChem, okay? And you say, okay, I think I know MedChem, but what I'm really learned from MedChem is that I'm more interested in the cancer biology side. So could I switch to cancer biology? Okay, and oftentimes we'll let a student do that, okay? The same thing with bioinformatics, okay? I learned, you know, I think I know what I got out of bioinformatics. I can use what I learned there, and I want to apply that to the microbiome project. So yeah, so we'll let students switch, okay, and things. But if you're going to jump around, that's not the ideal situation, because you're not going to get the experience that you really need. You're not going to, you know, get the problem solving, you know, skill sets and so forth that we're hoping that you will get, okay? And part of what this is all about is being able to do deep research, okay, is to dive deeply into the question that you are researching, okay? Not taking one semester of independent research on a small topic that ends after 3 months, okay? A lot of these problems cannot be solved in 3 months, okay? They take years, but you can actually make substantial progress by working on them over a period of time. So if you just take the minimal, not the minimal, but the research, the middle track, where you take research experience and advanced research experience, you have almost a year, 2 semesters of research experience. That's significant, okay? If you take the full track, okay, you have almost 2 or 3 years of experience in research, okay? Those things are extremely valuable to you and to employers, okay? So keep that in mind, okay? So when I started, I said that this is not only for students, but this is for faculty as well. So if you're a faculty member and you think that you want to start an RFI stream, the opportunity is there, okay? What this system allows you to do is to actually get free time to do research and get teaching credits for it, okay? So it frees you up to do some of these things. Now, if you're a faculty member, obviously you need to talk to your dean or about it, or your department chair and things, but this is something that is supported by the entire university, and we're hoping that it'll actually spread across the university over time, okay? And so I believe that there is support for it, okay? And it's something that if you're really interested and you think that there's an opportunity here for you as a faculty member, you should please email me, come talk to me, whatever, and or so. But you need a research topic, okay? You need a project, okay? We don't just sponsor one-offs, okay? We want you to be working in a field that really benefits the students, okay? So if you have an idea like that, you're already doing something like that, please take advantage of it. So I'll stop here, okay, and take any questions or so, and go from there, okay? Yes?
Can you do 2 at once?
No. Okay, so let me explain why, okay? So these courses, okay, meet twice a week for 2 hours each, okay? And if you enroll in it, you're also expected that you'll probably have to put in time after class, okay? Outside of the 2 designated class times, okay? And the reason for that is that research is unpredictable. You're doing experiments, you're incubating samples. You know, I used to have to come in at 3 o'clock in the morning, you know, to pull off my experiment or to start an experiment sometimes, okay? Because that was the time that, you know, you had to collect your time point or so. We don't expect that you guys will be coming in at 3 o'clock in the morning or anything like that, but we do want you to realize that you know, the experiments do take time, and that you might have to stop in the lab to do something, to add a reagent, to pull your experiment, you know, whatever, okay? So that's important, okay? The other thing is that when you go to register, you'll see that these courses, that there's designated time slots for them, okay? And some students say, well, you know, I can't dedicate that amount of time. It interferes with my schedule and things. Well, the only reason those time slots are there is to accommodate the registration process. All the professors are flexible. These classes meet at whatever time is needed, okay? Whenever you have free time. The professors are always there in the labs, okay, and stuff. They talk to the class once it starts, and they figure out when the best times are for everybody to meet, okay? And things. So again, don't be put off because, oh wow, I got 4 hours a week and it's 2 complete blocks of time. That's not the case, okay? We're as flexible as we can to provide you with the opportunity to do this. We realize that research is not, a 9 to 5, cookie cutter kind of slot thing, okay? Yes?
Can a non-matriculated student enroll in a course like that?
Non-matriculated, no. Any other questions? Yes.
I know you were talking about how GPA is a requirement, but if anything, if you speak with a faculty member and the interview goes well, it could be, but what about for transfer students if you don't have a key GPA?
That's okay. We'll look at whatever transcripts you have. Okay? So those are not barriers, okay? They're always, we're problem solvers. We'll figure out a way, okay, to assess it, okay? So don't not, okay? Yes.
I'm a senior, but I still have maybe roughly 1 or 2 more classes that I would have to take, and so I won't be done this coming spring. I'll have another class in the fall. So would I still be able to join in if I were to get accepted in the spring?
Yes, okay. I actually had a senior come to me last week with the same thing.
How many classes would you be able to take as a senior?
Well, even if you just took one, it would probably be a benefit to you, okay? So, again, if you're really interested in it, don't hesitate, okay? Yes? Yes, just all of our faculty have office hours, okay? The office hours are posted. You could just email them and say, when would be a convenient time to talk to you about an RFI, and they'll get back to you, okay? If you have trouble, come over to the STEM office and see me, and I'll make the introductions for you, okay? And things. I am located on the 5th floor of the STEM building in the administrative offices, okay? On the first door. You can't get by me once you come in the door. I see everybody, okay?
Just a little clarification about those courses. The research topics course is not a prerequisite for RFI. That's actually what you enroll in as a participant.
Exactly. Yes. Okay. Those are the research streams that this one slide, and the things that if you have that one of those sheets, okay, that lists the research streams that the faculty are working on. Those are the choices that you have to participate in RFI courses, okay? So each faculty runs both a 2903 and a 3903 section of those courses, okay? Now, 2903 is sometimes offered usually in the spring. 3903 is often offered in the fall, okay? Now, a number of faculty are actually offering either some of their streams in the summer 1, okay? So you were asking, how many courses could I take? If you wanted to go in summer 1, you could actually take one of the streams, okay? So you could get 2 under your belt if you wanted to do that, okay? Any other questions? Yes?
Oh, you said something about to get into the class you need I forgot what it's called.
Petition.
That, yeah.
Yes. Okay. So when you register when you go into register, okay, what automatically happens is it registers in the system, and then that goes to the faculty stream, the faculty member who runs the stream, and he or she is able to grant your petition to enroll in the class. Okay. All right. So that's the way that works. Okay. Any last questions? So again, if you have questions, don't hesitate, okay? I don't bite. You know, I'm pretty laid back. I actually wore a tie for you guys today. I hardly ever do that, okay? So please come and see me. I do have to rush off because I actually have to teach a class right now, okay, till like 7:30 tonight. Okay, so again, my apologies for having to run out, but thank you all. I really appreciated your attention, and I hope to see some of you, okay, in the RFI. I really do, okay? I think it's a great opportunity, okay? Thank you.